This is section 2.2, part C, normal distribution calculations. So how do we solve problems involving normal distributions? When you use the four-step process, the first thing you need to do is state. You need to express the problem in terms of the observed variable x. Next, you need to plan, so you should draw a picture of the distribution and shade the area of interest under the curve. Next is the do part, where you perform the calculations. This means you need to standardize your x to restate the problem in terms of the standard normal variable z. And then you need to use table A and the fact that the total area under the curve is 1 to find the required area under the standard normal curve. Finally, you will conclude, which means you need to write a conclusion in the context of the problem. On the driving range, Tiger Woods practices his swing for a particular club by hitting many balls. When Tiger hits his driver, the distance the ball travels follows a normal distribution with mean of 304 yards and a standard deviation of 8 yards. What percent of Tiger's drives travel at least 290 yards? So the first thing we need to do is our state. So we're going to let x equal the distance that Tiger's ball travels. The variable x has a normal distribution with a mean of 304 and a standard deviation of 8. We want to know the proportion of Tiger's drives where x is greater than or equal to 290. So for the do, we're going to draw a picture that represents this. We're going to mark where our mean is 1, 2, and 3 standard deviations away. We're then going to indicate where that x value is and shade what we're looking for. So we're looking for greater than 290 yards, so we're going to shade to the right. On the do, the first thing we need to do is standardize that value. Remember, z is equal to x minus the mean over the standard deviation. Our x value is 290. We're going to subtract the mean of 304, and then we're going to divide that quantity by 8, and you're going to get a z-score of negative 1.75. Now you're going to look at your standard normal table, and remember, you're going to find the row that has negative 1.7. You're going to find the column that has 0.05, and where those two intersect will tell you your area. But remember, your table tells you the area to the left of negative 1.75. To find the area to the right, we're going to do 1 minus that area. Our area was 0.0401, so if we do 1 minus that, we're going to get 0.9599, or about 96%. And if we go up and look at our graph, this does make sense that it should be around 96%. It is covering almost the entire graph with the shading. So our conclusion is that about 96% of Tiger Woods' drives on the range travel at least 290 yards. Now, what percent of Tiger's drives travel between 305 and 325 yards? Again, we're going to start with our state. So we're going to, again, let x equal the distance that Tiger's ball travels. We want to find the proportion of Tiger's drives, with 305 being less than or equal to x, and x being less than or equal to 325. Again, for our plan, we're going to draw the picture. We're going to locate the two x values, and we are going to shade between. This is going to give us an idea that it should be a little less than 50%. Next, we're going to do the do. To do this, you will have to standardize both of those x scores. If we standardize x as 305, we're going to get 0.13 as our z value. And if we standardize 325, we're going to get 2.63 as our z value. Now remember, you are going to find the area to the left. So for the 305, it's going to tell me the area from here all the way over. For the 325, it's going to tell me the area from here all the way over. So to find the distance between those two, we will need to subtract those two areas. So we're going to take our z value of 0.13. You're going to look it up in your table, and you are going to get an area of 0.5517. Then you're going to look up the z value of 2.63. That's going to give you an area of 0.9957. You are going to subtract those two areas, and you're going to get 0.44, which we said from the graph it should be a little less than 50%. So our conclusion is that about 44% of Tiger's drives travel between 305 and 325 yards. Sometimes you can encounter a z more extreme than those appearing in the table A. For example, if we're looking for an area to the left of z equals -4, it's not given directly in the table. The z values in the table leave only an area of 0.0002 in each tail unaccounted for. For practical purposes, we can act as if a zero area under the range of table A. So if we're looking for the area less than -4, we would call it 0. If we're looking for the area greater than +4, we would also call that 0. High levels of cholesterol in the blood increase the risk of heart attack or heart disease. For 14-year-old boys, the distribution of blood cholesterol is approximately normal, with a mean of 170 milligrams of cholesterol per deciliter of blood and a standard deviation of 30. What is the first quartile of the distribution of blood cholesterol? Again, we're going to start with our state. So we're going to call the cholesterol level X. It is important that you define what your variable is going to be. This variable has a normal distribution with a mean of 170 and a standard deviation of 30. The first quartile is the value of X with 25% of the distribution to the left. So we're going to look for an area of 0.25. Again, we're going to draw that picture. We're going to find 0.25 of our area. So to do this, the first thing you need to do is you need to go to table A and you need to find an area that is close to 0.25 inside the table. The closest area to 0.25 is 0.2514. And remember, you're going to work your way out into the top to see what the z-score is that corresponds. The z value that corresponds to that is -0.67. Now we know our formula to find z is that z is equal to x minus the mean over the standard deviation. If we plug in the values, we know our z is -0.67. We know that we're missing our x, but our mean is 170 and our standard deviation is 30. So the first thing you would need to do is multiply both sides by that 30 to get it out of the denominator. 30 times -0.67 is going to give us that -20.1, but we're still left with x minus 170 on the other side. So to get the x by itself, we are going to add 170 to both sides, and we will get x is equal to 149.9. So our conclusion would be that the first quartile of blood cholesterol level in a 14-year-old boy is about 149.9 milligrams per deciliter. Now you can use your graphing calculator to find some of these. When you're finding the area, the Normalcdf command on the T1 TI-84 can be used to find the area under a normal curve. So if we look at this again, remember that Tiger Woods' average drive is 304 yards with a standard deviation of 8 yards. So if we want to find what proportion of Tiger's drives on the range travel at least 290 yards, you are going to hit second and then the VARS button, which is going to take you to distribution, and you are going to choose option 2, which is Normalcdf. Now, your lower bound is going to be 290, and we want to find something larger than that. You're going to pick a number that is much larger than that, so we can go ahead and pick that to be 400. Our mean is 304. Our standard deviation is 8. We can close that command and press enter, and it will give us an area of about 96%. Now, if we look at the second one, this time it told us to find the value between two different drive lengths. So now we know our lower bound was that 305, our upper bound is 325. So we're still going to use that Normalcdf. We're going to use our lower bound is 305, our upper bound is 325, our mean is still 304, and our standard deviation is 8. And this is going to give us an area of 0.445. Now, because on the last one we had to work backwards, We can work backwards on the calculator. To do this, we are going to do the NV norm. So to do the NV norm, you are again going to hit second and vars, which is distribution, and choose option 3, which is NV norm. So this is the inverse of the normal distribution. Now we want to put in the percent or the area, so we're looking for an area of 0.25. We know our mean is 170 and our standard deviation is 30. When we work this backwards, we are going to get 149.76, or if you just do the NV norm of 0.25, it can tell you the z value that corresponds of negative 0.67. So let's check our understanding. Cholesterol levels about 240 milligrams per deciliter may require medical attention. What percent of 14-year-old boys have more than 240 milligrams per deciliter of cholesterol, remembering that it's a normal distribution with a mean of 170 and a standard deviation of 30. So the first thing you need to do is find your z value. Remember, it's x minus mu over sigma. Our x value is 240, our mean is 170, and our standard deviation is 30. And this is going to give us a z-score of 2.33. Now we want to find greater than this. So which ones require medical attention? Remember, on your z-table, it's going to tell you all the things to the left of it or less than. So the area to the left of 2.33 is going to give us 0.9901. To find the area to the right, remember you do 1 minus the area to the left, and this is going to give us 0.0099. Or we can say about 0.99% of 14-year-old boys require medical attention. People with cholesterol levels between 200 and 240 are at considerable risk for heart disease. What percent of 14-year-old boys have blood cholesterol between 200 and 240? Again, we are going to find where we're shading on our graph. We know that the mean is 170 with a standard deviation of 30. So we are going to have to find two different z values when x is 240 and when x is 200. So we're going to do 240 minus 170 over 30, and we're going to do 200 minus 170 over 30. The first one is going to give us, again, 2.33 like we just had. The second one is going to give us 1. So to find the area to the left, the first one is going to give us an area of 0.09901. And the area to the left of a z value of 1 is going to give us 0.8413. So the first one's telling us from here all the way over. The second one is telling us from here all the way over. To find what's in between them, we are going to have to find the difference. So we are going to subtract. And that's going to give us an area of 0.1488, or about 14.88% of 14-year-old boys have cholesterol level between 200 and 240 milligrams per deciliter. What distance would a ball have to travel to be at the 80th percentile of Tiger Woods' drive length, remembering that his mean is 304 and the standard deviation is 8? So if we're looking for the 80th percentile, that means the area we're looking for is 0.8000. You first have to find the area that is closest. So the closest on the table is an area of 0.7995. And the z-score that corresponds to that is 0.84. Remember, our formula is z is equal to x minus mu over sigma. We know our z value is 0.84. We're solving for x. Our mean is 304, and our standard deviation is 8. So the first thing we're going to do is we're going to multiply both sides by 8. So those are going to cancel. This is going to leave me with 6.72 is equal to x minus 304. Next, we're going to add that 304 to both sides, and that's going to give me 310.72 is equal to x, or a ball in the 80th percentile would travel around 310.72 yards.